At three different forms of quadratic equations. And when I say that, there's something called vertex form, factored form, and so that you know, and hang on just a second, I'm having a bit of difficulty over here on the left side of the screen. Factored form is also in some books called intercept form, just so you've heard that. And then standard form, I can almost write today, is also in some books called general form. And each of these forms gives you a certain amount of information. There's some information in common that you can tell by just looking at that sort of equation. But then each of them also has something very unique that you can tell about that equation. So here's an equation in vertex form. Here's an equation in factored or intercept form. And here's an equation in standard or general form. One of the things that's going to be really important is this coefficient of the x squared. So this one is -2. Nothing shows in this one, so it's that +1 out front, and again a +1 out front of this one. That number is going to do double duty, telling us some really important information about this parabola. So both the direction and the scale factor you find from the coefficient, and yes, you should add this into your notes, and I can almost spell coefficient today, of the x squared term. If it's positive, opens up. If it's negative, it opens down. And the number, not ignoring the positive or negative, is the scale factor. And I'll talk a little bit more in just a minute about what the scale factor tells us. So here, the coefficient of the x squared is -2. So what I know, and write the word opens, that this one opens down when I graph that parabola. +1 because it's positive. This one will open up, so opens up. +1 again, so opens up. So the first thing I do is look at that sign of the coefficient of the x squared term to see if the parabola opens up or down. Now the scale factor is the number without the positive or negative on it. So the 2, the 1, and the 1. And here's what this tells you. And again, if you can graph this somewhere, do a sketch somewhere off on the side, you have a little more room on your sheet than I did on mine. If y equals 1, x squared looks like this. We would call that normal. That's the parent function, so that's the normal curve. If you have y equals 2x squared or y equals 10x squared or something where that scale factor is greater than 1, it's a vertical stretch. And I kind of think of it as if I took this original function, the red function, and I graphed it on, or I put it on some silly putty, and then I stretched it up and down with my hands, it would stretch into something like this. So if the scale factor, ignoring the positive or negative, if the scale factor is greater than 1, it's a stretch, which means if it's less than 1, like y equals 1/2, x squared, it's a shrink. So that's how it changes the shape. It's going to actually make this almost more like a shallow sort of bowl. This one's going to be a very steep-sided, this is going to be very shallow-sided compared to the normal y equals 1x squared. So scale factor of 2, and I'm going to expect you to write this on your worksheet, means it's a stretch. Scale factor of 1 on each of these means it's normal. It's not a stretch or a shrink. It didn't change that basic shape of the parabola. Every single type of equation, every single one of these forms, you can tell which direction it opens and the scale factor just looking at the coefficient of x squared. Where it differs is what other points you're going to be able to talk about. So the key points in vertex form, you can tell me what the vertex is. In factored form, which is also called intercept form, you're going to be able to tell me the roots, which are also the x-intercepts, which are also the zeros of the function and the solutions of the function. Remember, it has a bunch of names. And then when it's in general form like this, you can tell me the y-intercept. You're not going to tell me the vertex when it's in this form or the intercepts when it's in this form. You're only going to tell me the y-intercept. So the vertex, remember from the yellow packet, you change the sign here, you keep the sign here. So the vertex is the point +5, -6. So if I were to graph this, I go over to +5, -6, which is my vertex, and I know this thing opens down, and that's all I have to say. Now I can tell at a glance it's not going to have any roots because it never touches the x-axis, but just glancing at the equation, you don't have to tell me that. You should know from the last unit, on the x-axis, it's when y is 0. So we're really solving the equation to find the intercept. 0 equals x minus 6 times x plus 8. This should look really familiar. Remember that zero product property says if you multiply these two things together and you get an answer of 0, the only way that happens is if x minus 6 equals 0 to begin with, or x plus 8 equals 0 to begin with. And when I solve these, my roots become the point where x is +6 and y is 0, and x is -8 and y is 0. So if I'm going to sketch this, I've got the point -8, 0, and the point +6, 0, and I know that this thing opens up because of that coefficient of x squared, and so that's a very rough sketch of what this parabola looks like. Don't forget to put your arrows at the ends of these because they're infinite. And the y-intercept, again, on the x-axis, y is 0, so we can substitute the 0 in. On the y-axis, x is 0. So y equals 0 squared plus 6 times 0 plus 12, which means when it's in this form, it's pretty easy to see that when I substitute 0 for x, I get 12 for y. So this thing is going to cross at 0, 12. I really can't read that. Let me see if I can get this out of the way and go back. 0, 12 is my y-intercept, and my parabola opens up. And then you're going to be expected to do some matching. We're going to be really nice this year. And if it's in vertex form, you're going to be asked to find the vertex. If it's in intercept form or factor form, you're going to be asked to find one of the intercepts. The thing that leaps out and bites me on the nose immediately is there's only one of these that opens down. And I know that the change in the equation to make it open down is that the coefficient of x squared is negative. So this one has to be C, the only one with a negative x squared coefficient. Remember, if I solve this, I'm going to get the point -4, 0 and +2, 0. Well, looking at this, they want the negative one, so m is -4, 0. The other one that they're asking you for a root is this one. So it's the other one, a, that is in factored form, and they're asking you for the positive root, so 2, 0. Here they're asking you for the vertex, so I look through and I find the one in vertex form that would match this. Remember, change the sign here and keep the sign here. So, and it makes sense looking at this that the x is +3 and the y is +6. And then the last one is the one that hasn't been used yet, so D, which I could also know because they're asking me for the y-intercept and they gave it to me in standard form. So my y-intercept is the point 0, -30. Now, on your first worksheet, I want to look very quickly at one of the problems, or a problem like it. It's not actually one of the problems. If on the first page they give you a parabola and they tell you a whole bunch about the parabola, but one thing they tell you is that the vertex is at, and actually let me go back and do a different one. I want to do one that opens down. The vertex is now at +4, +8, and they ask me to write the equation. So y equals, well, the x has moved right 4, so x minus 4 squared, and up 8, so +8. Remember, change the sign on this one. Don't change the sign on this one. but it also opens down, so I need to put the negative sign out front so that it opens down. And then on the back of those worksheets, you're given equations in different forms. For example, y equals negative 1/2 x squared plus 4x minus 8. So it asks what you can say about that. And the first thing it asks for is the vertex. Well, it's not in vertex form. You're not expected to pull out the vertex, so just write NA for not applicable. The next thing it asks for are the roots. It's not in factored form, so you're not going to find the roots. Just put NA for not applicable. Then it asks for the y-intercept. Yes, in this form, you should be able to tell that when I substitute 0 for x, this becomes 0, this becomes 0, and my y is negative 8. And then on all of these, you can tell me which way it opens. The coefficient of x squared is negative, so it opens down. And normally I want you to write opens down, but because the word opens is already there, you don't have to. And then what is the scale factor, and what does that mean? I expect to see. Well, the scale factor is the coefficient of x squared. It's the absolute value of that, so 1/2. Remember, the negative just tells me it opens down. The 1/2 is the scale factor. And what that's going to tell me is this is a vertical shrink.